Hello everyone, my name is Liko and I am an industrial engineering student at Universitas Gadjah Mada. Today, I'll be talking about what makes engineering unique compared to other fields, what it means to solve engineering problems holistically, and finally, I'll give an example of how engineering concepts, especially design principles, are applied in the field I'll be studying at the Faculty of Engineering, Universitas Gadjah Mada. Let's dive right in. So first, what are the characteristics of engineering compared to other fields, especially science? Science and engineering are closely related, but they have different goals and approaches. Science is focused on understanding the natural world. Scientists ask questions like, what is this? Or why does this happen? They build theories and conduct experiments to explain phenomena. Engineering, on the other hand, is about creating solutions. Engineers ask questions like, how can we make this work better? Or how can we solve this real world problem? So while science seeks knowledge, engineering applies that knowledge to solve human needs. Another key difference is that engineering is often constrained by real world limitations. These include budget, safety, environmental impact, available materials, and even culture. Scientists work in controlled conditions to isolate variables. Engineers don't usually have that luxury. They have to work with complexity and uncertainty. Engineering is also highly interdisciplinary. An engineer often needs to combine physics, math, computer science, economics, even psychology, depending on the problem. To summarize, while science explains, engineering builds. Both are vital, but their purposes are distinct. Now, let's move on to the second question. What does it mean to solve engineering problems in a holistic manner? A holistic approach means looking at the entire system, not just the technical side. In engineering, we can't just focus on whether a solution works. We have to think about how it affects people, the environment, the economy, and even future generations. For example, let's say we design a water filtration system. A technical solution might purify water perfectly, but if it's too expensive for the community, or too complex to maintain, or made of unsustainable materials, then it's not a good solution, at least not holistically. Holistic problem solving includes technical feasibility, does it work? Economic viability, is it affordable? Environmental sustainability, is it eco friendly? Social impact, is it accepted by the community? Is it ethical? Long term perspective, will it still work in 10 or 20 years? This mindset is what sets great engineers apart. They design with the full context in mind. Finally, let's talk about how engineering concepts, especially design principles, are applied in the field I'll be studying, industrial engineering. Industrial engineering is all about optimizing complex systems and processes to improve efficiency, productivity, and sustainability in industries like manufacturing, logistics, healthcare, and service systems. One example of applying engineering concepts in industrial engineering is the design and optimization of a manufacturing production line. Let's walk through the design principles theory applied to the situation. The first one is define the problem. The goal is to improve the efficiency of the production line. The problem could be a slow assembly process or high levels of waste, both of which are impacting the production speed and costs. Second one is set design criteria and constraints. The production line must be efficient, reduce waste and optimize time, safe, ensure that the workers are safe and the environment is conducive to good working conditions, cost effective, stay within the budget while improving efficiency, sustainable, minimize energy consumption and reduce waste, adaptable, flexible enough to accommodate changes in product design or volume. Third one is to ideate and model solutions. In this step, we consider different designs for the production line, using lean principles to minimize waste, incorporating automation where appropriate to reduce manual labor, using simulations and CAD software to model the production line and test various configurations. The fourth one is to analyze and optimize. Here, we apply key industrial engineering tools, work study methods to analyze the time and motions involved in each task, queuing theory to optimize the flow of materials and workers, ergonomics to design workstations that minimize worker fatigue and enhance productivity, cost-benefit analysis to ensure the changes are economically viable. The fifth one is implementation and feedback. Once the new production line is implemented, we monitor its performance. We look at the key metrics like production rate, employee satisfaction, and overall cost savings. Feedback from workers, our performance data will guide future improvements, allowing for continuous optimization. This entire process demonstrates how industrial engineers apply design principle, not just focusing on technical aspects like machinery, but also considering safety, efficiency, human factors, and cost effectiveness to create a well-rounded, optimized solution. To wrap up, engineering is a dynamic field that combines creativity, technical expertise, and problem solving to address real world challenges. Unlike science, which seeks to understand the world, engineers applies that knowledge to build solutions. As we've discussed, solving engineering problems requires a holistic approach, considering not just technical feasibility but also economic, environmental, and social factors. In industrial engineering, we apply these principles to optimize systems and improve efficiency across industries. Ultimately, engineering is about transforming ideas into practical, sustainable solutions that benefit society. Thank you for listening, and I hope this presentation has given you a clear understanding for the unique and impactful role of engineering plays in shaping our world.